Welcome to this session. In this session, we continue the discussion and integration. Now I have a problem here to find or what the value of integral d dx over x. Remember, so far what we have discussed is that integral of x raised power n dx is the same as x raised power n plus 1 divided by n plus 1 and then plus a constant c. But if we may try to use power rule here, let's see, we'll have integral. Now 1 over x is the same as x raised power minus 1 dx. So we'll be saying x raised power minus 1 plus 1 over minus 1 plus 1 plus c. But this reduces to x raised power 0 over 0 plus c. So there's a problem. There's a problem here. There's a problem because this working will result in our answer involving division by 0, which is not defined because division by 0 is not defined. So power rule cannot be applied here. Power rule cannot be applied to this problem. Now let's see how to solve the problem. Remember from definition, so integral dx over x is the same as integral x raised power minus 1 dx, or the same thing as writing integral 1 over x and then the x. So the question we ask ourselves, or what this one means, is which function has a derivative equal to 1 over x. That's really what this problem is asking about. What value or which function do you differentiate to get 1 over x? And from our rigorous work on differentiation, we know that if y is given by ln of x, then dy dx is given by 1 over x. So therefore, a function whose derivative is 1 over x is ln of x. So therefore, that will be the integral. So hence, integral of dx over x is the same as ln of x plus c, since when you apply d dx to this function ln of x plus c, we get 1 over x. And it is good manners to write ln when using these two absolute value signs to insist that ln can only be defined for positive values of positive numbers. So therefore, the integral of dx over x is always ln of x and then plus c if we are dealing with an indefinite integral. And so question 2, evaluate integral of e raised power x dx. Now the same problem. This one means that we are being asked to find a function whose derivative find a function whose derivative is e raised power x. And from our work on differentiation, we know that if y is given by e raised power x, then dy dx is still e raised power x. So a function whose derivative is e raised power x is the same e raised power x. So therefore, the integral of e raised power x dx is the same as e raised power x and then plus c. And then problem 3, evaluate the integral of a raised power x dx given a is any positive constant greater than 1. So this one, we can know the value to this if we remember the problem on differentiation on how to get a raised power x. So the question is, what function has a derivative equal to a raised power x? So if we know that function, then that would be the solution to this question. Now let's do some recap on what we did on differentiation. So if y is given by x, a raised power x, then this is how we carried out the differentiation. You introduce ln on both sides. So you say ln of y equals to ln of a raised power x. And using laws of logarithms, you drop this, we have x ln of a. So which means ln of y is the same as x ln of a. Now you differentiate both sides with respect to x. That's the process of implicit differentiation. So d dx of ln of y equals to d dx of x ln of a. Then d dx of ln of y will be 1 over y dy dx, which is equals to, now remember ln of a is just a constant, so d dx of x is 1, so just be ln of a. And then this means dy dx will be y ln of a, but y is the same as a raised power x ln of a. So dy dx is the same as a raised power x ln of a. So for us to have only a raised power x on the right hand side, then we need to have, remove it by dividing both sides. So we have 1 over ln of a dy dx, and then you get a raised power x. So what means that a function whose derivative is a raised power x is simply 1 over ln of a times a raised power x. Because if you carry out dy dx on this one here, so when y is given by this one, then dy dx will just be a raised power x. So therefore, the value of the integral, will be integral of a raised power x dx is the same as a raised power x and then divided by ln of a and then plus c. So that is what we have in general, that integral of a raised power x dx is the same as a raised power x over ln of a then plus c. So that's what we need to be knowing. So if they ask you to find, for example, the integral of 7 raised power x dx, then you should be able to say that the answer will be 7 raised power x over ln of 7 plus c. So that will be the solution. And then if they ask you to evaluate integral of, say, 1 over, say, 11 over 9 raised power x dx, then the answer will be 11 over 9 raised power x over ln of 11 over 9, then plus c. Can always simplify using laws of logarithms to get the answer. So that's how we interpret those integrals which cannot be obtained by direct power rule that we have already discussed. So the next session we do the second type of integration technique, what is called the integration by substitution method. Thank you.